For years, the technology industry prioritized model parameters and benchmark scores, but the recent pivot by companies like OpenAI into custom silicon signals a shift in focus from the brain itself to the body that houses it. Success now depends on the physical world, specifically the server farms and electrical grids required to keep these systems alive at global scale. This shift is turning artificial intelligence from a software product into critical global infrastructure, creating 3 specific battlegrounds that will define the next decade of competition. For enterprise leaders, surviving this transition requires a change in mindset. Stop thinking of AI as a tool you download and start treating it as a resource you must engineer and manage. The first battleground is hardware. To sustain growth, the labs building the most advanced models are moving away from the generalized chips provided by third-party vendors. This roadmap for OpenAI's custom chip illustrates the strategic objective. By engineering their own silicon, they are moving from a state of external compute dependence toward a fully controlled, vertically integrated infrastructure. The middle of this process focuses on inference optimization. Training a model generates headlines, but running that model for millions of users every hour creates the real operational challenge. Custom hardware allows these companies to manage the massive costs of those daily interactions. But even with custom processors, engineers are hitting a physical wall. Modern AI systems require a staggering amount of high-bandwidth memory to move data efficiently, creating a new bottleneck in the global supply chain. This diagram shows the tension between processor speed on the left and bandwidth capacity on the right. The organizations that successfully balance this collision will dictate the speed and cost of intelligence for the rest of the world. The second battleground is enterprise economics. As businesses roll out AI to their entire workforce, they are discovering that unrestricted use of frontier models leads to unsustainable cloud spending. This AI vending machine concept highlights the rise of model routing. Instead of using the most powerful model for every request, companies are implementing logic that automatically sends basic tasks to cheaper, smaller models to protect their margins. This financial rigor is necessary because the role of AI is changing. These systems are moving from chatbots that answer questions to digital workers that autonomously execute multi-step sequences. As we see in this roadmap for AI interaction, traditional user interfaces become optional as agents move closer to real work. Software is being redesigned so AI can navigate systems independently, managing entire business processes without human intervention. In this environment, the winning companies won't necessarily be the ones with the most intelligent models. They will be the ones that deploy digital workers most cost-effectively across their operations. The third battleground is geopolitics. Advanced AI capabilities have reached a scale where they are now treated as matters of national security and economic stability. Federal officials are now actively engaging with frontier labs, requesting staggered model releases and security reviews. Government oversight is moving upstream, influencing how and when new capabilities are introduced to the public. This intervention has sparked a global movement towards sovereign AI. Regions across Europe and Asia are now investing billions to build domestic data centers and local models to ensure they aren't dependent on a handful of foreign tech companies. This progression chart tracks the escalation. It shows how nations move from viewing AI as a strategic asset to full-scale government engagement, prioritizing national independence over simple access to software. While capital and engineering remain critical, model deployment is increasingly hitting a new, non-technical limit, the sovereign policy of national governments. The period of fragmented experimentation is giving way to institutional control, requiring a level of rigor typically reserved for core business infrastructure. This operational loop illustrates the requirements for the next phase. Leaders must establish governance, manage consumption like cloud spending, and redesign their core workflows for autonomous agents. This forces a critical strategic choice. Are you building an optimized infrastructure that your organization actually controls, or are you simply renting someone else's? In a landscape defined by infrastructure and inference costs, owning the stack is the only way to ensure a stable competitive advantage.